In order to study the concept of probability, it is necessary that we first define some terms. An experiment is a process with well-defined outcomes. For an example, we might throw a die. There are 6 possible outcomes. You could throw a 1, a 2, a 3, a 4, a 5, or a 6. Well defined. An event is a collection of outcomes. For instance, we might refer to the event an even number. In the example of throwing a die, the event throwing an even number would be if we were to throw a 2, a 4, or a 6. Classical probability is defined as the ratio of the number of favorable outcomes divided by the number of equally likely outcomes. So for the above example, if the event is to throw an even number, and this is some notation that we use, a big P, open a parenthesis, state the event, close the parenthesis, and then define the ratio. Well, there are 3 favorable outcomes, a 2 and a 4 and a 6, divided by 6 equally likely outcomes. And of course, that can be reduced to a half. A sample space is a collection of all possible outcomes for an experiment. We've already defined the sample space for the above experiment where we throw a die. That would be throwing a 1, a 2, a 3, a 4, a 5, or a 6, and there's the sample space. Now let's consider the experiment throwing 2 dice. And let's list the sample space. Well, we could throw a 1 and a 1 with our 2 dice. We could change the second one to a 2 and then to a 3, and we could systematically continue in this way and write out all of the outcomes there would be if the first dice was a 1. And then we could change the first one to a 2. And then again, going through this system, a 2 and a 1, change the second one to a 2, change the third one, or the second one to a 3, and on out like this until the second one goes to a 6. And then keep this process going until we get to a 6 and a 1, a 6 and a 2, a 6 and a 3, and then a 6 and a 6. So there would be the sample space for this experiment. Then we could find the probability of some events. Like for instance, we might find the probability that we would throw a sum of 7. So what we would want to do then is list out all of the outcomes in this event. Well, let's see, we could throw a 1 and a 6, a 2 and a 5, a 3 and a 4, and then realize that switching these 2 values creates a unique outcome. If we were to consider these 2 dice as being different in, say, maybe being different colors, like one is green and one is blue, well, a green 1 and a blue 6 would be different from a green 6 and a blue 1, even though their sum is the same. So we can continue then switching these until we wind up with all of the possible ways that we could throw a sum of 7 when we throw 2 dice. So there are 6 favorable outcomes. Now, if we think about this array that we have expressed when we list this sample space, we'll see that there are 36 different outcomes in this sample space. So there are 6 favorable outcomes, 36 equally likely outcomes, and that probability then would be 1/6.